Welcome to EDU World Space.
So in this question, we are given the material steel, right? And we are given the information that there is a rod AB and it is a thin wall vessel, right? We are required to find out the increase in the diameter along with the tensile stress. Now, the information that it tells us about this particular case is that the pressure that is being applied over there is 5 megapascal, right? The diameter is 100 millimeter. The inner radius is of 400 millimeter and the thickness is 10 millimeter. The elasticity is of 200 gigapascals and the epsilon is equal to zero point 0.3, right? So let's start with the solution, right? Now, the solution says that um, we are dealing with a thin walled vessel, right? And as it is a thin walled vessel, it means that we can just choose step number 8, right? Which states that two stresses that are applied to the cylinder are found by equation um 8.1 and 8.2, right? So equation 8.1 is that epsilon sigma, the stress, is equal to P times R divided by T, and P times R divided by 2T is equation 8.2. Right now, this sigma sub 1 is the circumferential stress, right? It is the circumferential stress, and sigma sub 2 is the longitudinal stress. Now, one thing to note over here is that there are no walls, right? And if there are no walls, so it means that um, this longitudinal stress will be applied, it will be applied to the piston, right? Not to the walls. So it means that sigma sub 2 will be equal to 0, right? So it means that there would be only this sigma sub 1 stress, right? So you can find it out by plugging in the values over here and calculating them. So that is equal to 200 megapascals, right? Now, since we have the value of sigma sub 1, right? So what we can do over here is that we are going to use the Hooke's law for two dimensions, right? And we can find the elongation that the radius undergoes, right? So this is the Hooke's law for two dimensions, right? Now, as we just discussed this thing that sigma sub 2 is equal to 0, so it means that this term, it will be, it will cancel out, right? There would be no term, it would be equal to 0. So we would be only left with sigma sub 1 divided by E. Again, just plug in the values and we'll get that it is equal to negative 10 raised to power negative 3, right? Now, this equation, it also gives us the information that this is the um, it gives us this information that the ratio of change in perimeter divided by the perimeter, right? So this change in perimeter, it can be um, change in perimeter, it can be written as this, right? So this is equal to del r divided by r. But before this, right, this change in parameter is written by del p, that is equal to del times 2 by r, right? And if we solve it for stress, right, then we'll get this fraction. And from here we can find out the value of del r, right? So del r is equal to strain into r, and it's, when we plug in the values, we get that it is equal to zero point 0.8 millimeter, right? From here we can find out the change in the diameter. So the change in the diameter is equal to del D, that is equal to 2 times del R, and that is equal to 2.04, 2 times 0.04, right? And that is equal to zero point 0.8 millimeter, right? Now this is the answer to our first part. Now the second part, that we wanted to find tensile stress. So for that we will assume that there is a longitudinal stress if there is no piston in the cylinder, right? So let's find out the value of longitudinal stress. So we have sigma sub 2 equal to P times R divided by R. Just plug in the values and we'll get that it is equal to 100 megapascals, right? So now what we are going to do is that we are going to take the equilibrium along the longitudinal axis, right? And we'll get this equation, that is P times pi times R square negative P times pi times R square sub AB, right? That is equal to the stress along AB times pi times R square of radius of the rod AB, right? So if we solve it for this variable, right, so we'll get our answer of the second part. So we have stress along the AB rod AB, right? So that is equal to P times R square negative R square sub AB divided by divided by R square AB, right? So just plug in the values and we'll get that it is equal to 315 into 10 raised to power 6 pascals, and that is equal to 315 megapascals, right? So this is the solution of our second part, and this concludes our solution for